Welcome to the MS Dev Show, episode number 145. This week, we talk with David Crook about using machine learning in Azure to program self-driving autonomous vehicles. Is one monitor better than two? Async await versus JavaScript promises. And we learn that Carl is a Cylon.
By your command.
This episode of the MS Dev Show is brought to you by Expose, the market leader of .NET and Java APIs for file business formats. Natively work with DocX, XSLX, PPT, PDF, MSG, MPP, image formats, and many more.
This week we have David Crook from Microsoft, machine learning expert and architect of Skynet. How's it going, David?
Architect of Skynet. Pretty good now that I know I'm going to destroy the Earth.
I wrote your intro for you. Yeah, but I mean, you might be one of the lucky few that survives, and then we can make a whole bunch of movies about that. That'll be exciting.
Well, I'm making sure I program the off button only so it's available to me.
Yeah, there you go. I would make it hardware-based, not software-based. Just a pro tip there.
Yeah.
Carl, what do we have for the comment of the week?
This week, our comment of the week gets a developer small business license for Expose Total for .NET, which includes all of the Expose.NET products in one package. And we got it from Anteo Almada, who commented on our episode with Oren Novotny. He said, great show. Thanks, Oren, for all your work on .NET, especially reactive extensions.NET. Just to comment on the card-sized computers, NextDock already has a laptop without the computing component. Just add your own, nextdock.com. So if you go there, it's actually really cool. It is literally, like he said, it's the laptop shell where you actually take that credit card-sized in compute card that we were talking about, and you just slide it in. And if you want to upgrade your computer, you remove it and just swap them out.
Oh, that's kind of interesting. So you just carry that around in your pocket. I wonder if I could pop that in my phone too.
Probably not.
Just have the same core with both devices.
Yeah, but neither of them are out yet.
Yeah.
So we're going to have to wait until at least the middle of the year. They both say mid-2017. So that will be, I think it would be really cool.
Yeah. Yeah, I mean, it's kind of nice just if you just had one machine, but, you know, I guess the alternative obviously is just really, really good synchronization of all your stuff, which is... which I think we're pretty close to. I think we're pretty close to having that reality. I mean, I even use different platforms, right? And I can kind of move files and stuff around without even thinking about it. And software now, like Slack, I mean, it treats all your devices the same. Like I can sit here and kind of switch between computers, and the context doesn't really matter.
Except when somebody messages me, 10 of my things go off all in one shot.
Yeah, that's the downside.
But from the data perspective, I mean, I'm no longer worried about losing much of my data because I have it in OneDrive and Dropbox and all the different cloud solutions. When I get a box going, it's get my box starter script, get my, applications like Visual Studio on there, and then I'm just good to go.
Yep, absolutely.
So if you
starter script.
So if you want to get mentioned on the show like Anteo, send us an email to feedback@msdevshow.com, comment on Facebook, YouTube, or Stitcher. We especially love those 5-star iTunes reviews.
Okay, let's jump on the news. Why I don't do unpaid overtime and neither should you.
Sucks out vacation and family time, I'm sure.
So what's this one about, Carl? Oh, Carl, you've locked up.
I am still going, so can you hear me?
Yeah, we had to reboot Carl.
It's become standard in much of our industry to do like 45, 50, 60-hour weeks. Mm-hmm. Really, that's unpaid overtime, especially when I'm being paid salary and not hourly, which isn't too common, I don't think, or I haven't seen it much. And, I think a lot of the expectations that balance, we don't push back enough as to employers. And for some employers, it might mean you don't get the job, but I think a fair amount are open to that concept as long as, you come to that agreement ahead of time. Mm-hmm. I know when I negotiated with my current employer, I told them, like, if you want me to work above this hourly threshold a week, don't offer me the job. Mm-hmm. And I got the job. So, I think it is absolutely doable for a good chunk of people out there.
I'm
Yeah.
just going to hang on to this into the back of my mind here, Jason, just in case anytime this comes up.
Oh geez, oh geez. Yeah, so it's kind of interesting, and the whole workforce thing is kind of supply and demand, right? I mean, it's always
Hmm.
whether it's if you have the luxury of being able to do that whenever you're in the job market, that's great. Um, he sort of puts his foot down, and so obviously he has other options. If the job market were to switch, then people are going to lose the option of kind of dictating how those kinds of things work. So I don't know. I kind of have mixed feelings about this. I mean, like I get it, and I think it's good to have that work life balance. And it's kind of interesting. Have you guys used this Delve Analytics at all, where it tells you, you know,
Oh, the Outlook analytics, where
well,
you work so many hours out of your normal working time.
yeah, so I get a report all the time, and I can go look at it, and it tells me how many hours I've been working like outside of standard work hours, and it tells me how many emails I've sent during meetings and who I collaborate with the most. And I don't know, the results of this, I never know what to make of it, because it's saying that I'm working, like 10 hours outside of working hours, but I see that as like good work life balance. I have that flexibility to do that. I can leave early today, and then tonight I can work for 3 hours, and it's not really a big deal. So, I mean, the
Well,
reality
I
is,
think part of that too is,
yeah,
I mean, you are balancing it. You aren't
yeah,
working that full time and then going home and working an additional 3 hours.
yeah,
So, I think kind of the point of the article is like for a lot of industries, I mean, you get paid an hourly wage, and when you work more, you get paid more.
hmm,
So if you are salary and you're working the 60 plus hours a week, you're essentially not getting paid for a substantial amount of hours worked.
absolutely. And so honestly, something must be broken at that point. Like something is wrong, because we know that productivity goes down like after 40 hours. And there's some exceptions to that if you're doing kind of a variety of work, but if you're in that situation where you're working 60 hours a week, you're probably, I thought statistically it showed that you were, less productive actually on average. So
Hmm.
it shouldn't all be based on hours. I was just pulling up my analytics here to give you some stats. So it's funny too, because there's goals in here, and I can edit the goals. But email hours. So in the past week, I spent 9.7 hours on email. It said my goal should be less than 10. So apparently I'm succeeding. Meeting hours should be less than 10 hours, but I've done that for 13 hours. Focus hours, 27.5, which my goal is greater than 10. So I'm killing it on focus hours. After hours, I'm at 5.7, and my goal is less than 0, which doesn't even make sense. And then it's kind of funny, like, the people I'm collaborating with. So one person I collaborated with 5.3 hours, which is my boss, so that makes sense. Um, I love this too. Meeting habits, multitasking in meetings. 3 hours, I've done that. Recurring meetings, 4 hours. And then I like this too, because it shows company average, which I actually won't disclose. I don't want to disclose like Microsoft company averages.
We
Um,
overwork ourselves when we do other things in meetings.
yeah. And then there's one in here that always makes me feel bad too. Like percentage of emails read by me, sent to group 9%. I think it's because I'm on a whole bunch of different lists. But there's some stats in here that show that like I don't read everybody else's email, but they read mine. Um, so actually, no, this one
Well,
is
you are
flipped.
the boss.
Well, now that I look at it, though, it actually is flipped. Apparently I've improved this. I've been reading everybody's emails, but they haven't been reading mine. So I guess I can't have it both ways. So I don't know. You just have to find your own balance. You have to work for an employer that's sort of on the same page as you. If you want to get, I think everybody should be evaluated by the work that they do, and that should be the focus. And it's almost kind of archaic that we keep talking about number of hours worked, as if that's a useful metric for anything. I think it's the same as number of lines of code written.
It's
Um,
also the value that you get out of it. Think about the number of hours you work as like a remote worker.
yeah.
If you work an extra 3 hours a day and you don't have to drive into the office.
Hmm.
Or, maybe you make a bunch of extra money that you wouldn't normally work on an hourly wage or something that would be otherwise unavailable to you. So, sometimes it's more about the value that you get than the actual hard metrics that you're receiving. So striking a deal. So, A good example would be I might overwork myself, but I have a family to support and it's difficult for them to get a job. I might take a job with a higher pay and higher hours and
Mhm.
overwork that because it's unfeasible to do otherwise.
Yeah.
And I wouldn't discount some of that as well. I think it just really depends on the value that you want and that you need.
Yeah, those are some really good points. In fact, I always every day I have this dilemma, like, do I go into work or do I work from home? Because I can, like, today I came in, but there's a high cost of that. I mean, today actually, because it's spring break here, traffic is not bad at all. But still, I'm going to spend an hour and a half of my day driving. So I have to offset that cost. That would be time. I'd spend at least half of that working extra at home. So I have to
Yeah.
balance that. Is it worth giving up time to, are these in-person meetings that important?
Yeah, and then when you go to work, you naturally have to go get lunch. Sometimes you might have to get dinner, and that adds in usually an hour or so extra there. But
Mm.
it's a 5 minute walk to the fridge right now, and I know I have some rice Indian stuff already there. I'm
Oh,
gonna
that
pop it
sounds
in the
good.
microwave for 3 minutes, come back and finish up some
Yeah.
emails. So
Well, fortunately, the cafeteria is like super super close to me, so I can get food really quick. But that's a different issue. Any final comments on that, Carl? Nope. Okay. Why I stopped using multiple monitors? This one's kind of fascinating to me.
I,
Carl, you're like
we
real.
lost.
You've really
Oh,
been Cyloning.
Hopefully it's a little bit better now.
There we go. That's better.
This
Yep.
one's really interesting because
Yeah.
he talks about it about being able to use one monitor to help him focus more on the task at hand and not get distracted by having things like Slack and Twitter and these other applications up and running, and being able to kind of use that to kind of sandbox you. He says that he's using, I believe, like a 24-inch screen as what he considers ideal, big
Yeah.
enough where he can have one program or two kind of split and get his work done. Anecdotally, too, I was listening to and Richard Campbell said that he has a 43-inch 4K
Wow.
monitor. Once again, it's a single monitor. Granted, it's huge. But I think it's interesting to move back to.
Oh man.
is he siloning on your
Yeah.
side?
Well, it's going good
There
on
is-
my side.
Yeah, Carl
I
can hear
sound
himself
great.
perfectly. Well, and all the audio listeners will be like, "What are you guys talking about?" Because we record separate audio tracks, so you're going to sound perfect there.
Yep.
But anyway, it's just for us in the here and now. So this whole thing I find extremely fascinating because, yeah, he's saying I want to go to one he basically switched to one monitor for the focus reason. This is like so against like how I've thought about things. I can't imagine going down to one monitor. In fact, anytime I have to use one, it kind of drives me crazy. I mean, even right now, like I have a Skype window open that's like, so 50% of my focus is on that, and then I have OneNote open with the show notes. So right away
Exactly.
either splitting the screen, or in this case I have it on a separate monitor. And
It's
then
not about.
yeah,
Oh, I was
go
gonna say
ahead.
it's not about multitasking. So I think his problem is that he'll have his work up on the left monitor, and he'll have
Yeah.
something that's not his work on
Well,
the
yeah,
right
it's on like
monitor.
Twitter, Facebook, Slack, whatever. Yeah, I think
Yeah,
that sounds like it's the real problem. I mean, there's
that's a
plenty of
behavioral
times. Yeah,
problem.
there's lots of times when in fact, he's talking about coding, which I can kind of understand. But I mean, how many times do you open up, like documentation, and you want to look at it side by side?
Yeah,
So
I have three monitors. I have one in the back behind me, which is for embedded platform. So occasionally I use that. Most of the
yeah,
time it's off. I've got my left one, which has my code, Visual Studio Code stuff up
yep,
and running. Then my right one is usually Chrome with like 10 tabs of different kinds of documentation,
yeah,
which is going to be, the platform, the framework, the high level architectures, and flipping between those, writing code, reference back, forth, find something on Stack Overflow. All right, how do I translate this into my problem?
yeah,
I don't know if I could go back. I did a couple of years in Microsoft Consulting Services where all you could get was you only got your 13-inch book because you were always on a plane.
hmm
Now I've got three monitors and it feels like heaven.
Well, the issue now is like, or I should say the solution we have now is like virtual desktops. But guess what? When I do virtual desktops, it really mimics the real world for me. I have one for like documentation, I'll have another one with the code, and I sit there and I flip back and forth. So I'm always mimicking that context change, and I get it that there's like an inefficiency there, but I need to. I don't know. There's so many activities where I need two applications, and I don't know. I guess he's probably a way better coder than all of us, and he's able to just code, just focus on that. And but I'm not at that point in my life, unfortunately.
I don't have anything memorized. How do I add two numbers or do a for loop? Sometimes it does. It's like
Yeah,
you've got like six languages memorized. You're like
I
going
know.
between Python, C, C++, SQL. It's like,
Yeah,
God, is
yeah,
it group by or group underscore by? Gotta
yeah,
look it up again.
exactly, exactly. Or is there a symbol for it? Yeah, no, exactly. Any other comments on that one, or should we move on? Of course, now I move my windows around and I can't. Okay, here we go. Uh, Ironically, link performance improvements in .NET Core. I found this one fascinating. The sort of secret improvements in there.
Yeah, especially since like when we hear talks about .NET Core, it's always about like, hey, we can get this your same code working everywhere. But we don't hear about like, hey, not only that, but we made it like a million times faster and better
Yeah.
in every way, shape, and form too.
Hmm.
But I think this was a really cool article just to like just really dig in and see like, hey, let's look at just link. This one thing that many of us use. We love the syntactic sugar of it. It's a great. Let's just look at the improvements that were made on this alone.
Yeah. So one thing they do for efficiency's sake is like whenever you're chaining some things together, they'll actually like save the results if they see that the expression is going to use kind of that same value. I think in this case they were using a count, right? They were doing an order by and then a count. The order by actually knows the count, for example, and then whenever you do the count, it can actually just reuse that information. So it's sort of evaluating that whole expression, so there's some efficiencies there because you can make a really simple order by function and a count function separately, but I think in this case they sort of have knowledge of each other and they're able to put some optimizations in there. So I don't know. Free performance is good performance, and that's what this is. It's giving you a whole bunch of free good performance. I mean, the only possible pitfall with any of this is you always need to understand what it's doing under the covers. I think with anything like this can be so dangerous, especially whenever you are hitting against a database. If you don't have a good understanding of what that end query looks like, then having
Select
this thing
star.
yeah. Well, having this get faster all of a sudden, you're just like, oh, good, that put a Band-Aid on that issue I was having. You might have some horrible issue that you're not even aware of. I mean, it could be a really inefficient query.
And once again, this was a benchmark. So,
Yeah.
there could be doing things like caching results. Well, if you loop through it 5,000 times, you're only executing it once.
Yeah.
So, I mean, there are things like that under the hood. Always understand, what it is that you're actually doing inside your code and what those, like you said, those optimizations are optimizing for.
Yeah.
That's also a good point is on a lot of the modern CPU architectures, if you do like a for loop and it's 1,000 iterations or 1,000,000 iterations of doing essentially the same thing, it'll memorize a particular kind of branching structure in the underlying logic. And you'll see that the first like five or so are kind of slow, but every single one after that is just lickety split lightning fast. So if you're doing a lot of times what I found is when I was benchmarking some of my own code, I found that my benchmark code actually was not benchmarking correctly because it did not replicate the environment that my actual runtime code existed in, where you had random people executing random things. I was like, oh, 500,000 people are going to access this. Let's just do launch off 500,000 tasks, let it hit it, and they all were like the same thing. It was horrible. It did not replicate reality.
I think ideally what you do there is then you do some instrumentation in the production system if you can. Obviously you want to do your stuff before that, but a lot of the tools in Visual Studio where you can see what's actually happening as it executes your code and how long those pieces are taking, then you can actually see how it's
profiler.
Yeah, so you can actually see the profile of how it's working, a little bit more in the real world. But no, that's a great point either way.
App Insights and Performance Profiler, those two things like together, you can. That's just magic sauce.
Exactly. 6 reasons why JavaScript's async await blows promises away. I didn't know we needed this article. I thought it was pretty clear, but but I'm glad that they wrote it because it shows like side by side how much simpler these expressions get. And I think halfway
Yeah,
down the
and
page,
he even groups them into like 6 distinct categories
Right.
that all make sense with the examples.
yeah, different patterns. I think number 4 for intermediate values, that's the one that always pops in my head, honestly. Because it shows, if you show a promise, and actually they should have showed the nested version before this, right? Which would be horrible because you just keep, having callback after callback. And there's some ways you can manage that, but it usually gets pretty ugly. Then they show promises where you return promise one dot then, and you keep doing the dot thens. But if you do async await, it's really value 1 equals await promise 1, value 2 equals await promise 2, and you just call, it just looks logical. I mean, I've always had, whenever I first saw, async await in C#, I always had this idea of like, I guess this is a way of decorating your code. But I always thought it would be kind of neat to, have the, I don't know if there's any languages that are like asynchronous like this by default, and then you sort of tell them to work non-asynchronously somehow. But I think the whole point is that we're getting closer to this world where basically on a per line of code, you are determining if it should be executed asynchronously. It still just bothers me that the asynchronous way is trickier, right? I'd like to see that just become, and I think this goes, obviously async and await goes a long way in making it easier. But yeah, however we can make this as transparent as possible, because really it's like, hey, I want you to go do this thing, and then I want you to take the results of that thing, and I want you to do this other thing. And it's crazy the hoops that we've had to jump through. And it used to be in the old, .NET world, like doing that was pretty much impossible. You'd always have to like, you really would have to wait for the first one and block the UI, just block everything. And so I guess I'm not really going to complain at this point because the place we're at is just wonderful compared to how it used to be. But yeah, I'd like to see this, even get easier and easier and better and better. This is a huge first step. Anything else you wanted to call out in here, Carl?
No, I'm good.
Okay, this just rocks my world though. One thing I did see online, somebody posted it sort of without comment. They showed like some really simple async await code, and then they showed the actual output. I think they were using TypeScript or something to that effect, and it was showing like the raw JavaScript file. I think it was going back to like ES6 or something. They were generating that code, and it was just like a ton of ugly JavaScript code. And then I just commented, sort of again without saying it's like good or bad. I said that's pretty much how C# works as well, right? You do async await and you get all this complicated IL, which is basically using a state machine. And I think at the end of the day, ultimately, it doesn't really matter, right? Because we want our code to look the way it should. And on the back end, even if it's a little bit less efficient, if it's slightly less efficient, it's not a big deal, as long as it's not like orders of magnitude worse.
Yeah, it's well, that comes down to you can totally write all that async stuff from scratch if you want to maintain it. You'll make it as fast as you possibly want.
Yeah, but you're going to screw up and your code is going to be buggy and it's going to suck, so don't do that.
Yeah, thank you.
Yeah. And then one last story here, shutting down Codeplex. Wah.
So Codeplex has been around for 11 years.
Mm-hmm.
And obviously with the popularity of GitHub and a few other sites, Codeplex has taken a real big hit. In fact, they even call out in this blog post that in the last 30 days before they wrote this, less than 350 projects saw a source code commit.
Wow.
Yeah. That's a pretty big dust farm.
A lot of organizations.
Yeah. So do they have like a button or something to like move to GitHub?
No, but they said that they explained here their plan on shutting down. That I think it's sometime in October they're going to be setting Codeplex to read only, and then shutting it down completely on December 15th. And after that, they'll have an archive that they will keep up also somewhere.
Okay, so GitHub has an import because there's instructions. There's a walkthrough. So if you do have something at Codeplex, there is a process. I was going to say, because whenever Google Code shut down a few years ago, they actually had a button in there to like migrate over to GitHub. So it looks like GitHub has. Oh no, sorry. This is on This is on Codeplex. There is a button to migrate to GitHub.
Oh,
Cool.
good.
Yeah, and then it takes you over to GitHub, and then you hit begin import. Okay, cool. Yeah, so there's a nice migration path.
And then they said that they will be preserving URLs. So if for posterity's sake, if there's something out there that points to some sort of source file, it'll at least go to the archive.
Okay, very cool. Okay, well, let's talk to David because he's got a whole bunch of cool. I don't know what do we call it today? We still call it machine learning. We calling it AI.
You can call it whatever you want. It was statistics, and then it was machine learning, and now it's AI. It was data science once. What was the other one that they called before data science? Data mining was machine learning.
Yeah, yeah, I remember.
I don't
data
know how
mining.
many names we got.
So what's going to be next? I mean, I don't know how you go up from like AI. Will it just be intelligence or something, or human
We'll call it
replacements?
singularity programming.
Yeah, yeah, singularity. Or it would be like HR, human replacement. Uh,
Human replacement. Oh, that's terrible. I think we're a long way from that, but
Yeah.
you know.
so from your perspective, I wanted to ask you like what machine learning means to you, because on the show we've talked about machine learning before, so I want to get your take on it.
Yeah, that's a tough one, because a lot of it I think focuses on like the statistics and the science of it,
Hmm.
and kind of the practice. But I kind of think that machine learning to me is more about the art of making machines intelligent and learning from information. So anything that that takes a machine and uses information to do something intelligent out of it.
Hmm.
I think it's a very broad description. I'm sure the academics are going to yell at me, but and that's what I'm going to go with, because it really is becoming such a broad thing these days.
Absolutely.
So what kind of projects are you working on right now that's exercising machine learning?
Oh man, now we got to get into some of the NDA stuff. We're going to try and keep some of it quiet, but there's some stuff that I can talk about on the side, I
Hmm.
think. So my Microsoft day job stuff, most of that's pretty secret, I think, and you'll see announcements later on around that. But on the side, I've got I think the most exciting one. It's exciting to me because a really novel thing to do with it is actually processing documents with machine learning. As crazy as that sounds, there's a lot of people are using image classification, which is taking an image and identifying what that image is, and a lot of folks are taking images and identifying like 6 things in an image,
Hmm.
and that's cool. It can say, hey, there's a horse, hey, there's a cowboy, there's these couple of things, but one of the exciting things is taking something like that and applying it to a real world problem. And in the health industry and in logistics, they have a really huge backlog of paperwork that has to be put into a federal standard. And we're actually using some of the same techniques and technology that's used for identifying, 10 different things in a picture, and using that to convert documents into semantic dictionaries of objects that can be put into databases and digitize them.
Hmm.
And the impact of that is literally allowing companies to ship 6 times as much freight and cutting costs by $30 million, and just huge. And I think the exciting part is it's based off of the same anatomy that's in the human eye. So that's kind of exciting, is
Hmm.
you're kind of following how like a human looks at a document and saying, okay, how do I take this and apply it to a machine so that a machine can look at a document in the same kind of structure that a human does and receive the same types of information, and actually digitize that in a way that this physical object can interact with a digital world that then is transferred across the globe to then interact with other physical objects, and using the cloud as like a backplane for transfer of digital information across geographically distributed physical things. As vague as that might sound, but
That all sounds way too easy. So, no, I'm
thanks,
just
man.
I'm just joking. And then you have some cool stuff too, like this. You've been teaching a remote control car how to drive, for example.
Oh yeah, that was a lot of fun. That's how the whole document thing got started.
Okay.
was so if anyone watches this thing, there's this really big conference called GPU Conference. It's put on by NVIDIA. And most recently in November of 2016, so just this recent November, they did this big showcase and they said, we're unveiling this new electronic race car series. I was like, cool, I like race cars, I like electric cars. But then they said, but it doesn't have drivers. And I was like, what do you mean it doesn't have drivers? And there's a picture of this thing that looks like a torpedo with wheels on it. And it's an autonomous Formula One race car that can go like 200 miles an hour. And they said, we're going to start making these. It's like, oh, I so need to get in on that. So me and a bunch of people who were watching that at the same time just started talking. And as usual, we go to a bar and we have this really brilliant idea. None of us wants to look bad after getting drunk and having a brilliant idea, so we actually execute on it. So we decided we're going to make a self-driving race car. The first one we made out of cardboard and distance sensors and an Arduino. And very, very simplistic reinforcement learning solution. So by reinforcement learning, what it means is that it starts off just randomly trying just random stuff, and it has no idea how to even drive itself, doesn't know how to not run into walls, it doesn't know how to go around a racetrack, doesn't know any of that kind of stuff.
So how does it know when it succeeds? Do you pet it or give it a treat? Or
yeah, you give it like a digital treat and you give it a digital punishment.
Okay.
So you get a little button and you push the button and that gives it a reward, and it tries to optimize for rewards. So that would be when it, if you know anything about machine learning, there's always a reverse pass down the neural network, and that teaches it this was good or this was bad for every neuron that fired. If it receives a reward over that time period between the last reward, it gets a positive reinforcement. Hey, I should make sure that I tune each neuron in that positive direction.
Okay.
Whereas if you give it the other button, which is a beating or a thrash, it goes the other way through the network and actually does the inverse of what the neurons had fired on. And it's a very slight tweak of every neuron being shifted in that direction. So when it starts off, all the neurons are randomly initialized. Think of like a child who doesn't know how to walk, talk, any of those things. Has some very basic functions. And through teaching, if your kids start saying bad things, bad kid, don't say those things. Your kid stop saying those things in front of you, and their friends laugh and giggle and think it's great. So they say those things to yield the reward of the laughs and giggles in front of their friends. So same kind of thing, but you can apply it to to electronics, and that applies not just to neural networks, but pretty much any kind of machine learning algorithm. So that was one. It started off the great thing was it was an Arduino, so you didn't have a lot of compute power there, and it worked pretty well. It learned how to drive around my garage without running into anything and could complete a track.
Yeah.
Aspose offers a powerful set of file management APIs with which developers can create applications, which can create, open, edit, and save the majority of popular business file formats. Their product range supports a multitude of file formats, including Word documents, Excel spreadsheets, PowerPoint presentations, PDF documents, OneNote, Outlook, Project, Visio files, popular image formats, and many others. Aspose produces APIs for .NET, Java in the cloud, which can be utilized in almost any modern language available today. Visit www.aspose.com for a free 30-day no limitations trial. And if you get stuck, message the friendly support team for help. All technical support is offered free of charge. Remember, if you're a lucky winner, you will receive a free developer small business license for Aspose.words for .NET, a powerful toolkit to work with Word documents in your applications.
If you can hear me again, how many feedback loops did it take for your prototype here to drive?
Yeah, so that can be very variable depending on the optimizer that you use. For the cardboard car one, I called him Herbie, so I'm going to refer to him as Herbie. Herbie was a very simplistic implementation with a fairly simple network design. And a lot of what happens is it depends on the amount of variability and the quantity of variability that you get inside of your data that yields the results. So on average, when I would just turn Herbie on and he'd initialize his brain and wander around my garage, it'd take him about 20 minutes to 30 minutes before he's not running into anything. And then maybe another 30 minutes or so until he's kind of driving around like actually completing loops. Now, the issue, and why I say like I threw all those caveats there, is that sometimes I would discover that on occasion Herbie would decide that spinning in circles as fast as possible doing donuts was the optimal solution, and Herbie wouldn't really learn anything because his entire data set was filled up with rewards of basically doing donuts. So, and then when he's
that
trying
sounds like the fault of the parent.
Yeah. If you reward your child too much in one direction, that's what they're going to do. By God, they're going to keep doing it.
Doing donuts.
Because it ended up being more of a punishment for Herbie to explore, because every time he went outside of that donut loop, he would inevitably run into something.
Interesting.
And he would then realize, oh, that really hurt, but this donut thing feels really good.
Yeah.
So he would spiral into a loop of this like self-pleasing donut. And it's interesting when you work with these things, because you're like, man, there's so many things that you can draw about, humans from this as well. It seems like a psychological experiment.
Well, I mean, we're driven the same way, but it's just, more complex inputs and outputs.
So it seems like it's pretty easy to go down this pitfall of, the weird and loop and machine learning. So how machines wrong?
I kind of got the question.
We heard like every other word. Carl has no bandwidth.
I don't know what's happening here.
Yeah.
But, restating my question, it seems so easy to go down these pitfalls of donuts and stuff like that. How do we teach learning to avoid the false promises of donuts?
Donuts, the false promises of donuts.
That's so how do we, given all the pitfalls, how do we avoid all the false promise? So we've been given all these promises of the great things it can do, but here I have a reinforcement learning robot that's supposed to drive 200 miles an hour around a racetrack, and it's sitting there doing donuts going, look, I'm doing great. It's a complex answer, and a lot of folks are still learning about how to do this. So the answer is, and I can give you some more insights than this, but I just want to put out there that it's a currently researched topic and it's not completely solved yet. But the way that myself and a lot of other folks have gone about trying to resolve that is by you can actually treat a neural network or a series of neural networks kind of like an interface, and you can swap that interface out between different optimizers. So if you think about the car, and I was letting it was doing a reinforcement learning style to learn how to drive around the track. Well, the thing of that was that it was just a single feed-forward neural network, and the optimizer was reinforcement learning. So it had a series of states and things that it could pick, and those would be the inputs, and it has a series of inputs and a series of outputs that gave it the speed and turning direction. Well, the thing of it is that little piece there that makes the decision, the input and the output, can be put inside of a reinforcement learner, or it can be put inside of a supervised learner, or it can be put inside of a different type of unsupervised learner. What that means is that you can use a combination of allowing it to fully experiment on its own, and you can choose how much it wants to experiment on its own too. You can let it do that in a simulated environment, and then take it and put it in a, you ain't allowed to learn anymore. You're done. You're doing full-on like production stuff now. Or you can have it follow and just learn from somebody who's already an expert, which that helps bootstrap. So that actually gets to the second project. So the first one was this thing, and it barely went a quarter mile an hour. This thing was slow. It's made out of cardboard and servos. Yeah. The second one, we were like, okay, we need to go do the GPU conference thing. We want to make a race car. What's the next step? Mm-hmm. Went and bought a RC car that can go 35, 45 miles an hour. It's got a brushless motor, and you control that via PWM, and it also has an Arduino, but it also has this thing called a TX1, which is like a Raspberry Pi size supercomputer. NVIDIA makes it. It's super awesome. They just came out with another one that's even faster. But the thing of that was, it goes 45 miles an hour. You know, if the
Yeah.
other one decides to do donuts, okay, I can go stop it. But if this one decides to do donuts, man, it's out of here, man. Like, that's 45 miles an hour of like learning fury. You don't want to have to catch it. So the story was that to solve this kind of problem that you're talking about, we decided to make a simulator, and the simulator was a super realistic version of the car. So cars have centers of gravity, they have weight distributions, they have spring ratios, you apply torque, they have friction, the ground has friction, all these different components. We said, we're just going to make a simple version of this and see how simplistic we can get to make the car go on its own. So we made this simulator, and we did the same exact thing. It was a slightly different network, but similar to what the cardboard car had. We just had a little more sophisticated of a network this time. And we put this on the on the faster car, or in the simulator, and it actually followed us around. So in the simulator, it's a great place to learn, because the first time we were like, we're going to just reinforcement learning this thing all the way. But it turned out, because it picked random actions and our rewards weren't very well defined or close enough, it took it way too long to even learn how to drive in between the lines.
Yeah.
That it just wasn't feasible as a solution, because it couldn't even figure out how to drive between the lines. So what we did was, we actually had a couple of us from the engineering team drive the car around, record the image sequence data from each run, and then train the same neural network on that, and got a baseline that could at least complete the track. Now, reinforcement learning or any kind of AI means that you have a error, which means the best that the AI can ever be is a fraction as good or a shadow of my own performance. Well, we said that's not good enough. We want to be able to make it go faster. So then you can put it in reinforcement learning mode. So take the same thing, swap the optimizer. Instead of supervised learning, you put a reinforcement learning around the same algorithm, and then you let it experiment. Like 1% of the time, it takes a random action. And then it learns, oh, my time on this track was faster, or my time on this track was slower. It does that reverse feed, just like the cardboard one did, where it either gets thrashed for, oh, you went slower, or rewarded, oh, you went faster.
Yeah.
So it would continue to experiment 1 to 5% of the time until it got faster and faster.
That's
and
cool.
faster.
Yeah. Yeah, I mean, it's just trying random things, right? Like, what if I go faster on the straightaway? What if I, turn left instead of right here? And
Oh, it's super fun to watch, because like it'll be going like in a straight line, and then you'll see that 1% thing kicks in and it goes hard left. And you're like, why would you do that?
Yeah, maybe I'll try the brakes on the straightaway, like stuff that doesn't even make sense. But the crazy thing is, I mean, there's got to be like this minuscule percentage of like, it might figure out something like you haven't even thought of, right? Did that happen at all, where you saw it like, oh, I didn't even think of that. Maybe it figured out how to, like, if I do a hard left turn, slam on the brakes, I can actually flip over the wall or something.
Yeah. It hadn't done that too much, because the simulator we had designed was more constrained.
Has less quirks, yeah.
There was one when we upgraded the simulator. So we started off in a black and white simulator, and then we moved to like a desert, like hyper realistic, where we actually had water puddles, and it would lose friction if one of the wheels went in the water puddle, or it had dust and it could like obstruct the view with dust flying across and things like that. So when we went to that one, there was this one section where it had a fork in the road. It could go right or it could go left. If it went left, the left was a safe path, but it was banked and it had some rocks there, so it was challenging for it to get around that. The right side was a big jump, and it was this really epic-looking jump. So what happened was that it decided to go on the left side the first time around, and it got stuck into this thing where it never ever tried the right side. But it kept getting messed up on the left side because it would hit rocks and things, and you could see it trying different strategies. So the first time it went around, normally it would hug the very inside curve, because that's the fastest way to get around, is to hug the corner. But that's where we put rocks at. So you could see on each iteration, it gets a little bit and a little bit further away until it finds this like super optimal path to get around. And that was really kind of neat to see and watch, that every iteration it adjusted and moved a little bit further and a little bit further and a little bit further away from danger.
Yeah. Well, that sounds kind of like standard, like evolution too. I mean, evolution will go down these paths that it sort of picks a path, just like you said, and then you're stuck with that path, right? It's not like I'm gonna spontaneously get like tentacles or something. Like that path is just, it's not been taken. So now all you can do then is improve upon the path that you've chosen.
Yeah, and that's kind of where, like we were talking about, how do you deliver on the promises? Because now that you can see the path, you can see the fork in the path, and you're visually rendering this and seeing it and seeing the decisions that it's making.
Yeah.
Well, you can, in a simulation environment, or even in a real environment, you can do things like geofencing. In the simulator, we can do our own like fake version of geofencing and put a box around that fork in the road, and we can actually say, "Hey, you're here. Go right."
Yeah.
And just do that. And
So you can force it down a different path.
We can force it down a different path, and we can stick that into the learning as one of the things that it ended up doing for that. So you can incentivize it to go other directions, or just straight force it to. But that's where you're kind of like playing Lord over the ecosystem and kind of saying, "Oh no, I kind of need you to try this path out and see how you do."
Yeah.
And then that gets into the whole thing of launching simultaneous simulations, and like, okay, this one's going to go down the left path, this one's going to go down the right path. This simulation here, we're going to let a car just do whatever the hell it feels like. And that's one of the things that's been really valuable about having access to the cloud and like the GPUs, is that you just launch as many of these simulations as you want and let it go. And it's a lot faster than like, I have one computer and I can run 2 simulations at a time on mine because I have 2 GPUs on it. But that's 2 simulations on one machine. That's not, I need like 1,000, because when you get to really complex networks, it can take a while for those to update, like a really, really long while.
Yeah. So you do the initial training in this like virtual environment, and then what do? You put it in the real world, and then it finishes the training?
I try to. So I haven't gotten the guts to turn on live training in the real world yet.
Yeah.
Oh,
but you've used it basically in like trained mode in the real world?
Yeah.
Okay.
And that's where we decided we needed to go to the desert style simulator.
Yeah.
So there's an RC racetrack around here that's kind of like desert-ish looking, and the first simulator was black with like white lines and a gray car. And in fact, we trained it in third-person view. We didn't train it in first-person view, and we didn't position the camera right. We didn't feed it at the same frame rate, the same sets of variables that the real car got. So the real car gets a certain frame rate, has a certain amount of power, it has a certain view. The view is in a specific spot. The environment was brown, not black.
Yeah.
And that didn't work very well. So then we put it in the started running the training through the new simulator, and I have to go out to the racetrack to see how this thing works with the new one. That gets to the whole matter of time.
Yeah.
Yeah. Well, when I get more time, now I've got. We'll see.
Yeah.
It's fun to keep up with it, but it takes a while to build these things.
Yeah. And then Carl pasted in a Mario link where and I think we've talked about on the show before, where they use the machine learning to play Mario. Have you seen that video?
Yeah, actually, we based some of the concepts. So that was published by DeepMind at Google. And then they have a whole team that does that kind of stuff. So they open source a lot of the algorithms. You can take the algorithms and the general concept and use that in your own. So The cool thing about that one was it was just raw computer vision with the rewards and the punishments. And after they had let it go through for a long time, it had figured out the optimal way through the entire game purely on visuals with no, they didn't write any CV feature extraction or anything like that. It was just, here's a raw pixel input, and they stuck it into a convolutional network, and the convolutional network would output what action it should take. Jump, A, B, the different keys that you have as actions. So give it the current state, give it the actions, and I think they ended up upgrading to, here's a sequence of like 30 seconds, and then each 30 seconds feeds into the action that you take now, and you pop off the last frame, move it, and add a new frame on.
So is that something that I could do easily, or is this still like really difficult to do?
I would probably put it at pretty difficult.
Okay.
There's some frameworks out there, so you don't have to know Calculus 2 or 3 anymore.
Yeah.
Some of the great things are that Microsoft has come out with this thing called CNTK, and Google has come out with this thing called TensorFlow, and that removes the requirement to know how to do partial derivatives. It also removes the requirement to need to know what a convolutional network is. You just need to know, I need one. So you can program those. The hard part, and then now that you have GPUs in the cloud from Azure, you've got the hardware that you need. So you have the framework, which removes the hard math, and you have the hardware, which removes the supercompute that you used to need. The hard part now is that the frameworks still like to use their own proprietary formats for feeding data in, and that's a big pain in the neck.
Yeah.
And then the other part is you need to have the part where you can actually orchestrate and instrument of game so that you have data, so that in the correct kind of data, so that you can stick it into the correct proprietary format to then feed into your network. And that's where the bulk of the work ends up going. So like in the car simulator, for example, it took us 3 weeks to make a simulator and like 3 days to make the AI.
Yeah.
So because we had to properly instrument it, and we went through all this stuff, and then it's a back and forth kind of thing. And then once you get on team sizes, on my own box, it's a lot easier than it is. I have a team of 5 people, because now you have this whole thing of needing to share the data.
Yeah.
And, like one guy's going to extract data and put it into some new format that's going to be useful for building some algorithm. Then one of your AI network guys wants to consume that, but he generates some new stuff, and they're not necessarily syncing up properly. So having something like the Git of big data would be really awesome. Right now, there's like Azure Data Lake is a really nice solution for centralized data, but there's no version control on top of that big data for you. And that can make things really hairy when you start wanting to build things like this. And like I had one of my guys accidentally like delete all of the data lake, and we ended up having to call Microsoft support and be like, "Oh my God, the data is gone. Where's the data?"
Oh geez.
Luckily, like we called them within like a couple of minutes, and they were like, "Which subscription are you?" Okay, fine. Please don't push that button again. Like we give you full control, but like that doesn't mean you get to use it.
Yeah. Yeah, I'm just thinking like, if I don't know if there's, us that don't do machine learning on a regular basis. I wasn't sure if there was any way that I could actually get started. I mean, what things that would be interesting to me would be like video processing. I mean, I have this issue, and you can tell me how difficult this would be. Spiders build spider web in front of my security cameras, and the infrared shoots out and it bounces right off the spider webs. And basically what ends up happening is I wake up and it goes, "Hey, we detected 1,000 motion events last night from this one camera." And I look and it's all just like the spider web like moving in the wind. So I don't know if that's like something I can easily feed into a machine learning model and say, this is what a spider web on the camera looks like.
Yeah, that one would be a lot easier. So that one, actually, there's some good tutorials where you can gut and replace the source data. Yeah. So you have this, I remember I'm actually going to add the same security system you have. Somebody stole some surfboards across the street. So we're going to get that. But you get access to your raw data, if I remember right.
Yeah.
Yeah. So what you want to do is collect your images that have pictures of spider webs and your images that don't have pictures of spider webs. You don't really need a lot. There's this whole misconception about how much data you need. Maybe like 100 pictures of each one.
Yeah.
And then, you put that into somewhere in a directory, and it'll be the file path and then space one and that one is a yes, it's
Okay.
it's a spider,
Yeah.
and zero, it's not, and that's going to be your label file. That'll be like a CSV type thing, and you can use either CNTK or TensorFlow. You can use CNTK or TensorFlow. We can cut that part out. Um, you can use CNTK or TensorFlow to use their baseline image classification. And what would happen is, if you can get access to each image frame, you can actually send that to your little local computer and classify that as yes or no. There's a spider web in front of here. And then it's up to you to interrupt or whatever you want from there. So
Okay.
and it gives you back a probability. So it gives you back a 0 to 1. So 1 being spider web, 0 not being spider web. So if it's 0.5, it has no idea.
Yeah.
If it's like above 0.8, it's got a pretty good idea that it is a spider web. If it's below 0.25, that means it's got a pretty good idea that there's no spider web in the way.
Okay. Because I do also take photos whenever there's motion. So I wonder, I could even train that, people versus not people. That would be kind of an interesting thing. And then basically have it, send me a message if it says, hey, I'm seeing people right now.
Yeah, that would be a good one. In fact, I wouldn't, if I didn't want to go through that whole like learning about the deep learning stuff, the cognitive services has the face recognition. So as long as they're facing towards you or towards the camera, it'll pick them up.
Yeah.
I think it'll probably break down if you're facing away, in which case you'll want the person detector. But what's even more interesting would be counting the people.
Yeah. I'll tell it how many people are in there, and then
You
have
could,
it figured out. Okay.
yeah, you could do that. So there's a couple of things. So you could totally have it count the number of people, and it's not going to give you like well, it could. You'd have to make it a categorical thing. So this is the pro tip of the day. I'll give you the pro tip of the day.
Okay.
And sometimes you want a numerical feature back or answer back, right?
Yeah.
Like, how many stars is this? Is it 1 through 5? How many people are in the view? Well, you can't have 3/4 of a person.
Mm-hmm.
And you can't have, in a lot of these rating systems, you get 1, 2, 3, or 4 or 5. You can't have 4.5.
Yeah.
So a lot of people have been giving back they've been using the root mean squared error metric, which is for linear predictions, which is like basically any number in the universe. And then they also do a linear prediction, which is any number in the universe. So, the root mean squared error goes with the linear predictions. Anyways, that's horrible if you have like a discrete number of things that you can pick from, even though it's 1 person, 2 people, 3 people, 5 people.
Yeah.
Really, that's a categorical number of people, right? So instead of framing those questions as linear questions or regression questions, frame those as categorical questions and use what's called one-hot encoding to encode those categories for your answers. And you can probably just look up one-hot encoding. That'd be terrible to explain on the radio.
Well, so I could, but I think what you're saying is I could differentiate like 1 person, 2 people, 3 people, and then maybe I could even have another classification that says like more than 3, right? And just make those the different buckets that it falls into.
Yeah, and you can have a lot of success with ImageNet is 1,000 something buckets, and it's very, very accurate. So, there's a great example of if you've got over 3 million images that are hand labeled, you can make over 1,000 buckets.
Yeah.
So make sure that you have good variation and distribution between the buckets that you have. So like like for example, if you have, let's go back to the spider web one.
Yeah.
If you have a spider web and it always occurs, and when there's a guy with a red sweater, is it detecting the red sweater or is it detecting the spider web?
That's a good point. Yeah.
So make sure that you have the good variation. That's why people always say like, oh, you need tons and tons, you need the world's information for this. But the reality of it is that you just need the variation for the expectation. And in fact, if you take the world's information, you might actually do more harm than good, because you might have overrepresentation of one thing. And that gets into the whole socio-economical issues of machine learning that people are going on about, like auto discrimination kind of stuff. And that would be, the result. Auto discrimination would be a result of overrepresentation of a particular scenario within your data set, or underrepresentation. You can have both.
Yeah, I think that's because I've heard of that. That's like I don't know how much have you looked at that? Isn't that like I mean it's looking at some of the biases that are already in like the data set that you're feeding in, right? So this thing is biased toward a certain type of person, and so you feed that data set in, and all of a sudden the machine is now has the same biases, which is pretty messed up.
Yeah, well, it gets back to the ethics of doing your job, right?
Yeah.
Like, I think eventually we're going to have some form of like committee and regulations around this, because the impact that it has is huge. And will we have a certification for data engineers to feed algorithms? God, I hope so, because like it's going into self-driving cars, and if you didn't do it properly, and the same kind of skew that goes into a self-driving car that forces it to crash is the same kind of problem and concern where you didn't get the correct variation. Now then you get into the whole question of, well, how can you possibly encapsulate all of it? And I mean, you could probably just go on for months debating that whole topic.
You're kind of scaring me now, because now I'm picturing my self-driving car is actually running some experiments to, it's just like a human driver would do the same thing, right? Like anytime, when I was in Wisconsin, the roads are bad. You start doing like brake tests, and you hit the gas, and it's like, what's my level of traction? And now I'm picturing machines doing that, but maybe less responsibly. It's like, oh, the road is perfectly good, but what happens if I swerve left just for like a fraction of a second? Does that make them more alive or more dead?
That's where you hope that, yeah, right. That's where you hope that they didn't deploy a reinforcement learner to production.
Yeah.
But, on that note, though, there's a distinct difference between your experiences and the robotic experiences. And that's that you, as Jason, experience individually, and you share those experiences through social interaction, which some people have a better way of taking advantage of or not. And then think about like when you tell something, oh, when you feel the slipping on the right tire, just push the brake a little harder or whatever. Yeah. Like, how good are you at that when somebody tells it to you versus when you actually do it?
Yeah.
Now, the distinct difference between your ability to do that and a machine's ability is that they take all the information of all the cars, and then they share that on the same brain and redistribute that same brain that has learned from every experience across the entire globe back in. So the reality of it is that they iterate and experience far more things than we ever could imagine, far faster than we could ever imagine.
I never thought about using some of that actual data to do that learning. And then you're actually giving me a little bit of hope too, because with these self-driving cars, they always use them in sunny weather, on some highway that is perfectly straight. And I know that Tesla has some more advanced stuff than that, and I've even seen people like use it on like a snowy road with like no lines. But I'm still thinking like there's situations where I can barely drive a vehicle. It's super slippery. And then I always think about the scenario too where you get this, especially in some of the hillier areas. If you have a hill and it's pure ice, as a human, I might, I'm just like, what? I took that hill yesterday. It was already slippery, and I know that there's more ice on there now. So I'm not going to go that way. And the car isn't isn't going to know that, or maybe it knows now. Maybe it knows based on the fact that like a car went there 5 minutes earlier, and then it shared that data.
Yeah.
Like, hey, these people died because this was a slippery hill. But anyway, I think you're giving me a little hope because I like the idea that that's just that the different weather and like they can focus on on sort of how they incorporate new data into their machine learning algorithms, and then later in these different conditions, let's say it's low visibility raining, they can just add that as like additional data, and they already know that like the theory behind it is sound, and it will will sort of fully optimize around that. So you give me a little bit of
Yeah.
hope for those situations.
I think other things to think about would be think about all the things that you're doing and needing to do when you're driving.
Yeah.
When you're driving, you're not thinking necessarily about driving. I mean, you've got 3 kids. You've got the kids like shouting in the back, playing the trumpet, like,
Our DVD
Dad, what are we
isn't
doing for
working.
dinner?
Yeah. I
And
have
you
to
have to like
pee.
drive down a slippery road while dealing with them beating you upside the back of the
Yeah.
head and like thinking about what am I going to do for dinner? Oh my God, I didn't do my taxes.
Yeah.
The machine doesn't have taxes or children.
Yeah.
So it can singularly compute on the task at hand. And we've already seen some of the results of this where it was actually Tesla who did a good job with it. They had one of their cars actually see an accident before the accident happened, and the car that the guy was in started applying the brakes before that accident ahead happened. And then the accident happened, and he was already pulled off in a different lane, braked, and completely out of the way across all sides because it has
Yeah.
sensors across the entire vehicle. It can pull maneuvers that, like, they're superhuman. You look at like what Audi can do with their like super awesome race car that goes around the track. It's a Formula One race car driver. I mean, do you
Yeah.
think you can compete with that? And these
Yeah.
machines are beating those guys.
Well, again, I think those are such well-known conditions. That's what's been worrying me historically is just that these cars, I just find me, and maybe it exists. This is like an exercise for the listeners. Find me, blizzard condition with ice, and show me a Tesla driving on that where you can't see anything. And guess
In
what?
autonomous mode.
And yeah, in autonomous mode. And guess what? The tire tracks, they go into the ditch that are in front of you, and that's all you have to go off of. Like, and I know it's a totally unfair scenario, but the reality is we're going to be in that situation whenever you can tell the car, hey, I want you to get me from this point, from point A to point B, and you have to do it autonomously because guess what? My car doesn't even have a steering wheel because the machines have taken over. How does it handle
Oh,
that
yeah.
situation? And sure, you have GPS and that could be more accurate. But I'm just really thinking on these edge scenarios. What does it do?
Oh.
Does it give up? Does it, I don't know. Does Jesus take the wheel? I don't know.
Jesus, take the wheel. God comes from above.
No, I don't know. I'm nobody has really been able to answer how that
Well,
situation is handled.
There's also more telemetry in the vehicles than what you necessarily see. So GPS
Sure.
is one. So you break down the problem by a series of like larger to smaller problems. So the
Yeah.
GPS is likely not even being used for that type of problem domain.
Right,
So the
right.
GPS
Because it's
is
sort of
I'm on the
untrustable.
road.
Yeah.
Yeah, well, so then they typically equip LiDAR and computer vision. Now, both of those are probably all right. The LiDAR is going to give you actually not the snow conditions. It'll, you maybe, but I doubt it. That's going to be a close distance, other cars are around me kind of problem.
Yeah.
The computer vision, that could give you the snow, no snow thing. But I think what's going to really give you the intelligence is an internal momental unit. So on my race car, we ended up figuring out that with the slippage issue, it turned out to be nice to have a IMU, which gave us several axes of rotation, acceleration, so forth and so on. And we would feed that in right alongside the computer vision. So when you think about the self-driving cars, they're not my implementation for my car was super simple because I don't have a lot of time. But for these cars, they're huge stacks of computer vision and judgment and multiple networks feeding into judgment networks. And there's actually a really great Udacity course on it as well that would be worth looking into. But anyways, I think by adding these extra sensor feeds and combining those together into a higher level judgment algorithm is where you're going to see that performance happening. And then the fact that all the machines can learn from each other is going to assist as well.
That's why you're giving me some hope is that fact right there. So, I mean, I get it. Like, it's going to be a solved problem, but everybody right now is just like, you know what? You're going to see 40% of cars on the road are going to be fully autonomous in 3 years. And I'm just like, what? Like, I just don't buy it. So my big question to you then is going to be, how many years before you'll be able to get a car that is fully autonomous? Let's say no steering wheel. So I'll kind of make that.
No steering wheel.
I'll make that
and buy as a consumer with my money.
Because here's the thing, like you can sit there and say Tesla all day, right? You can say, oh, just get a Tesla. Like they're doing all this until they take out the steering wheel. Like there's that feels like the chasm. Like if you need a steering wheel, then it's like, wait a second.
So Mercedes has already built one without a steering wheel.
Yeah, but I'm saying so let me give you the criteria. No steering wheel, and you can drive anywhere in the continental United States.
It has to be affordable for a wealthy individual, not like a super wealthy.
I'm actually okay with any limit because I guess it depends on whether or not we bring the laws into it.
I'm not sure if the Mercedes one doesn't do that already. Mercedes has one. It's the only breaker would be that it's like a $10 million one-off concept.
Okay. Not
like a commercial vehicle. And I think that one might be able to do it. Now, the issue is going to be like in your icy roads kind of scenario.
Yeah.
But in that condition, I don't trust half the people that live around me anyways.
So I mean, just to be clear, like humans are not good at this either. But I mean, because I've talked to, I had a friend.
They just decided to not do it.
No, they were they were going on a country road, following the tracks, and kept following the tracks. All of a sudden, they're in the ditch, and there's the car in front of them, also in the ditch. They follow the tracks right into the ditch. I mean, there wasn't even enough information for the human, and maybe the car could have some additional sensors, but I don't know. The other thing is that, and I feel I'm sorry for being such a Luddite and being like pessimistic on this.
Sure.
But the reality of the tech right now, like my car, I'll get it'll rain or something, or I'll get a little bit of dirt splashed up, and I'll sense on my camera lens, and I go to reverse, right? And this feature I count on, which is being able to see behind me, it's completely neutralized, and the car's like, I don't know, I don't know where you're going anymore.
Luck, dude.
Yeah. So, and obviously there's more sophisticated sensors. Like I get that, but I still pretty concerned about those things being rendered useless. I mean, we heard the one Tesla crash. I mean, it saw like a glare. And again, I know those problems will get worked through, and I get that.
Yeah, but how many of them were successful versus if you took the same quantity of cars and put those on the road, I would want to see on an average population how many normal people would have crashed for the same number of Tesla cars, because Teslas are rare, they're not all over the place.
No, I totally agree. Yeah. No, the machines are clearly better. Like this will happen, and I know it will be better. So I want to make that extremely clear. I'm just, this whole idea of like,
you're going to be there with your bunker.
Well,
let
me change the criteria. I'll get to the real heart of the issue. Okay, so all three of us on this call have kids. Okay.
Yeah.
What year will you feel comfortable taking your children, putting them into the car and inputting the destination and having it drive, and it's raining, snowing, whatever, having it drive 45 minutes? What year will that happen?
Oh, that's a tough one. I think, sticking my daughter in there is different than me getting in there.
Uh-huh. And what do you think, Carl? What year? Oh, he's Cyloning, so he's just like pleading the fifth. You can't even hold it. Oh, there we go. You're back.
I was going to say being a smart aleck depends upon...
Oh, man. We just heard being a smart aleck. I really should have taken you. I should have taken you out of the call. Let me take you out of the call, or actually drop, and then I'll recall you. Because I want to hear your answer.
Where is Carl based?
He's in Wisconsin, so he's closer than you.
Yeah, it's just weird that he has. I've got better, better connection. I'm clear across the country.
Yeah, we're gonna need to use machine learning to recreate Carl.
Oh,
All right. Am I
that's
back?
clearer.
Yeah, you're back. Okay,
More
so
clear.
what year, Carl?
So, being a smart ass, I said which kid
Yeah.
because
God. All of them, Carl.
Yeah, we're
No,
not going to get into that kind of discussion
no,
today.
I would like to think that
Oh, he's breaking up again.
10 years.
10 years.
10 years?
Okay.
Yeah, I was thinking probably closer to 10. I think 5 for me and 10 for my daughter.
Okay.
Look,
That's funny. That's funny. Yeah, because I said a year ago I said 10 years, so I guess my answer will be 9 years from now. So
Yeah.
I think that's the new bar, though. I think that's the bar. But
when you would be willing to stick your kid in it.
Yeah,
Oh,
so
man.
these people that are, I mean, because I hear so many people that are like next year, like this is
No
going to be a
way,
thing.
dude.
Yeah. Just until you are willing to put your the year that you're willing to put your children in there, that's your actual prediction. That's what I count.
Yeah. I mean, there's all these wonderful things that it can do, but like, you see like where it is really, it's kind of like being part of making the sausage. I know how that sausage is
Oh,
made
yeah.
and behind the scenes, how it gets made. I'm like,
Yeah.
I feel really good about it. Like one day it's going to get there and I'm super excited, but like, I don't know, man. Like that's kind
Yeah.
of like it, but it has to be like the same time when they turned on autopilot for the airplanes, right?
Yeah.
Like, do you think those planes take off and land completely by themselves and fly like 26 hours to Australia fully like by the one guy up there? There's all sorts of autopilot type
Yeah.
controls and GPS correction and coordination and all that kind of stuff that happens. So I think it's going to be similar even to that.
So anyway, Carl, do you have any other questions you want to ask him, or attempt to ask him?
No.
Okay. Carl knows his limits when he's on a bad Skype connection. Okay, so Carl, what do you have for the dev tip of the week?
You guys can hear this. We talked a while ago about having emoji. It looks like if you get a domain name that's emoji.
Okay, so for those of you on live Skype, you can have emoji URLs now, and you can register these, Carl.
The .us domain.
Oh,
It's
.ws.
small.
Okay.
So you can do that with that restriction, which I still think is pretty cool. I know that they are looking to expand that to other domains, but right now that's our limitation. But I still think it's pretty cool.
So you can have ghost new.ws. You can have smiley face, ghost, kiss blow.ws. Somebody took poo.os already, or .ws, of course.
Oh, you got to buy all the naughty ones. Those will sell for a lot.
Yeah. I just bought triple poo.
Triple poo.
www.triplepoo.ws. Anyway, okay, so David, there's a game that we play on the podcast. I need you to pick a number between 1 and 4 inclusive. Oh, and you got to tell me the answer.
4.
4. Okay, perfect. So this is a game for kids, but I'll ask you. Let's see. Would you rather be running as fast as you can and trip to land face first in a patch of grass? Sounds wonderful. Or be running half as fast before you trip and fall face first into a patch of gravel?
Grass.
Yeah.
Grass for sure.
Absolutely. Okay, Carl, try to pick a number. This is... Wait, I heard a laugh. Pick a number quick, Carl.
2.
Okay. Would you rather have to pluck the long hair sticking out of your grandfather's nose, or have to pluck the long hairs growing from the moles on the back of your grandmother's back?
Grandpa.
Okay.
Yeah.
Okay. That was pretty easy. Oh, let's see here. What do we have? Okay, so David, where can people find you online if they want to learn more and hear what intriguing things you have to say?
Oh, so I've got a blog which is dacrook.com.
Okay. Okay.
Crook.com.
Perfect.
And you can follow me on Twitter at Data4Bots.
That one's awesome.
With the number 4, the actual number.
Yep. Perfect. And Carl's been collecting a whole bunch of links as you've been talking, so we'll have links in the show notes to all these different locations about things that you've been talking about. Carl, where can people find you when they can hear you?
You can find me on Twitter at Carl Schweitzer.
Perfect. And you can find me at ytechie.com or on Twitter at twitter.com/ytechie. So David, thank you so much for coming on here and talking to us about what I think is some really cool applications of machine learning outside of just looking at, some raw numbers and things like that. So thank you so much.
Well, thanks for having me. And it's exciting to talk about it too.
Absolutely.